want to talk about data unit tests and what they are and why we need them. But before, let me ask you a simple question, like, do you have problem with your data? Can you raise your hand, please? Yeah, so you see, not feeling alone. So yeah, that's what I want to talk about. So let's go into the agenda. And what we have, basically, what I want to talk about is begin with a short introduction. Then I will define what are data unit tests and explain their importance when you build any kind of data products. And I will also present some frameworks to perform data unit tests and also show some live code. And finally, I will tell you a bit more how we are tackling that at GetYourGuide, my company. And yeah, I will conclude and open for questions. I'm really looking forward for any comments that you have or things that you think you are doing and are working great. So yeah, let's introduce. So I'm Theodore. I'm working at GetYourGuide. So in my company, we basically build a marketplace for travel experiences. And in my team, we're responsible for the recommendation and the ranking of experiences in the platform. So that means that we heavily rely on data to achieve our goals. So that's what we call basically we are building data products. And this is why I want to talk about data unit tests. So basically, data products combine code with data. And in classical software, it's actually quite common practice to ensure the quality of your code with automated tests. But here, the focus is really on testing your code. To ensure the quality of your data products, you need to validate your code also because you're using it, but also your data. And one way to validate them is actually to have data unit tests. But actually, I want just one thing to step back. So if you work on an organization that have multiple engineering teams, so any reasonable, as soon as you have a kind of certain size in the company, the code, basically, you probably, the code that is owned by your team, and probably that's the one that have the most full context when you change it. Like when you change something, you know it, and if there is something wrong, like you are looking for it in some way. You know when you are changing things. However, the data that you are using is probably not produced and transformed by your team, but by other teams that have probably not the full context of how you are using this data. And also the other things is like you have probably a lot of data sources that you need to use in your data products. Like as an example for us, like we have around 15 data sources that we need to combine for our ranking or recommendation algorithm. And I don't think we are really crazy in there. I think there's people that can go way more than that. Yeah, that's what I want to say. So the data unit test basically the idea is to verify some expectations that you have on your production data. So basically, I think that we need to make a clear distinction between testing your algorithm. And so, for example, if you want to test your code and that your algorithm is able to handle some null value, that's a unit test, like a classical unit test. However, if you want to test that your data set do not have null or like not too many nulls, that's basically where this is a data unit test. You want to check that your production data that you will use or to train a model or things like that do not have some certain properties. And so things like, for example, that you would like to test in some data unit tests, you would like to check that the mean, the max, or the average of the column value is okay. Like if you are computing some kind of conversion rate or click-through rate, it probably should be between 0 and 1. If it's negative or more than 1, you probably have something wrong in your data set. So you might want to verify that you not have missing value or maybe not too many missing values. You want to verify that do not have duplicates in some columns, or that you have the number of sample is reasonable. So if suddenly your number of samples jump from around 10,000 to 10 million, probably there is some joint condition that have been done wrong somewhere in the middle. And yep, so with that, we'll now have an idea of what's data unit tests, what we are trying to do. And I want to give you a look at some of the main framework to perform them. So the first one I want to talk about, I think there was already some tutorial yesterday in the morning about Great Expectations. And I think that's the most active project I've seen. And it's also support most of the formats, so SQL, Pandas, PySpark, and it also render data documentation, which I think is pretty great. So it's like human readable documentation of the expectation that you have on your data. And yeah, that's the pretty interesting, I mean, the first one I think we can talk about. Then I think the other one that is pretty interesting is Pandera. So it's quite active also. And it has no company behind, not like Great Expectation. And still they manage to have quite some stars and still pushing some new features. Like for example, now you have these pandas. They had these pandas. That was the core idea, but now they also plugged in some way with PySpark. So it's quite recent. But then basically you can validate your PySpark also with that, your PySpark data frame. And but maybe it's like more focused on validating the schema, and there is no validation. Then you also have like a very big one from TensorFlow data validation, which is part of the TensorFlow extended ecosystem. And actually I was pretty surprised that's not very active currently, and do not have that many stars. I was expecting a bit more, but it's pretty interesting, and I think that's one of the first one. Yeah, the thing is, it's pretty tightly integrated with the rest of the TensorFlow ecosystem. So if you don't want to go with TF record or things like that, then it looks like pretty much more complicated to do your pipeline with this to test it. And finally, I think the other one that's Soda, which is basically, from what I've seen, I didn't really try really in depth, but it looks very similar to GE, but it's more recent, so can have a look at it. And there are others vendors also that are providing SaaS, but that's the one where you can basically see the code. I think like they have an open source libraries that you can try. And yeah, so to conclude, Great Expectation is the most feature complete, and that's what I want to talk about now. So let's dive into the key features. Sorry, it might be a little repetition if you went to the Great Expectation tutorial, but they have this concept of expectation, which is some assertion that you have about the data. So basically a data unit test in some sense. And the most common use case is implemented. So if you want to check that a certain colon is between 0 and 1, they already have that, so you don't have to re-implement it. Or like that you don't have too many nulls. Like all these kind of things, they already did it for you. And also, of course, if you have some very specific use case, then you can still add your custom use case, like specific logic to it. Like if you have any kind of weird, like not weird, but very specific to your business logic test that you want to do on your data, then you can also implement it. Then they have this concept of data profiling. So basically, you can use some data set that you know is correct to build a draft expectation. So you will still need to work on it afterward, but at least the idea is that you will not start from scratch. You already start from something that is based on the data that you know is good. Then, of course, you have this data validation. So basically, you can validate a new data set with a defined collection of expectations or collections, or a collection of expectations that you have. And then you can do specify some alerting via email, Slacks, if something is wrong. So if one of your tests fail, basically. And finally, pretty nice thing is this data documentation. which auto-render documentation of your data, and you can think of it as like a constantly updated data quality reports. That's a pretty cool feature of Great Expectations. But yeah, let's dive into an example. I think like some code's worth 1,000 slides. So I will go. Can you see it here? Perfect. Is the size okay? Yeah, perfect. So here, what I want to do is, sorry, I'm losing myself in this slide. Yes. So you want to create some I want to show you how to create some data unit tests using Great Expectation, and because I'm French, we'll talk about wine in this. So actually, there is a wine quality data set, which is composed of two subsets: a red wine data set that we will use basically to create some tests on it, and then we'll have the white wine data set that will try to validate it. So then in the first thing, basically what we'll do is, so we will install Great Expectation, and then yeah, I'm using Databricks, which have also some free tier, so that's my personal account. So it's also what we use in my company. It's pretty cool, pretty interesting tool. But it also proposes like a hosted notebook, so I think it's interesting to show it in this. So then we'll set up on Databricks, and for this, so for sake of time, I will not dive in like the internals, but if you want to look into how I set it up in Databricks, then you can just copy the notebook. It will be in the link of the presentation that I will share after. And then finally, we can, what we get basically, we get a data set, we get some Great Expectation, and then we can load our first data set, or our wine data set, the red wine, and we basically will look at the quality and one of the other dimension, basically. So what we'll do, we set up the Great Expectation, and then we can do the fun part, which is building some expectations. So the first thing that we would like to check, for example, is that the quality actually in documentation, they say it should be a value between 0 and 10. So let's do that and check what we have. And indeed, the test succeed, and we should have value between 0, like you say that I had this specific values, and I even get some counts, so all good. Then the second thing that we will do, another expectation, is about the sulfates distribution, and we'll make sure that the sulfate distribution stays the same in our data set. And so for that, what I can do is applying a Kullback-Leibler divergence test, which basically means if the histogram of is different, have some kind of difference, then the test will fail, basically. So basically, we can run it, and at the end, like also we get some output. We say what are the different bins and what are the value for them, but not very user-friendly. But what you can do is then you say, okay, I save my suite of expectation, and now I can generate some kind of data documentation, like all the tests that I've just created. Now I will render it in the data doc, and basically then you get some kind of documentation which says, okay, I have two tests. The first one, the quality, it should be in this range, take one of these value, and the sulfates should have this distribution, more or less. All good so far? Yes? Which distribution do I use to compare in the histogram? No, I didn't compare anything here. I took the red wine data set, and I looked at the distribution of the red wine data set and say the next, and that's my test basically. I expect any new data set that I put into this to have the similar distribution.
Okay, yet it could not have failed this test.
No, there was no test. We were, I mean, exactly, because right now we were just saying it was not a test. So the question was like, was about the test. There was not a real test in the sense that we say, look at the data, then build a histogram on it, and then do a test to verify that the same data have the same distribution according to the histogram that was built on the same data. So the test will always succeed in this sense. So that makes sense?
Yeah. Thank you.
Okay, great. Yeah, now we have our tests. Of course, we should have more than one, but I think 2 is enough to show in this example. And basically now we can load our white wine data set, which is very similar, looks the same. And now what we can do basically is run our test on the white wine data set, the test that we created on the red one, and to make sure that does it make sense. And indeed, let's check. So there always have this pop-up. But basically here we see we have two tests, but one of them failed. So the quality succeed, and actually you get this kind of report like that's all the value that we indeed saw. But the sulfates, actually we get an error, and we get like, okay, this is what it should have been, that is what we expected, and this is what we saw. I think that it gives you kind of a great bootstrap when you want to do any kind of, I mean, first it will alert you that you have a problem, and then also you can see directly what seems to be wrong. Like you don't have to dive into the code or need to reload the data set in some sense. And that's it. Sorry, that's it for the live coding. I will go back to the presentation. Yes. Up. So in the last part, in this presentation, I want to talk about how we use data unit tests at GetYourGuide. But first, I think what is pretty interesting is to share like some of the incidents that we had in the past that trigger these initiatives. So for example, what happened is that when we have a change in the data structure that led to some duplicates in our recommendation system. We also had some missing feature that we in our daily production data set for our prediction to predict. And also it already happened that once that we use the wrong column for scoring. Like this is the kind of thing that's hopefully this data unit test should be able to catch. And so basically this incident led to action to avoid reproducing such incidents. And what we did basically is, for example, so we introduced great expectations to validate our recommendation data set. And we do that before we push them to our customers, so that if there is anything wrong, then we'll have basically a data set that is not up to date, like from the day before, but at least it's not something that is completely wrong with wrong score columns or something like that. We also have built in-house some kind of event validator, which is running regularly and checking some specific values that we have. And also we most recently introduced some kind of health check as part of our continuous integration pipeline. And basically also we do some kind of, we'll open source some library to do some kind of sampling. So basically that you can run this health check that helps to basically also run this health check as part of the CI. So you take the production data, you sample it, run it through your health check, and if the results are okay with the expectation that you have, then you can deploy basically, or like any new version, then get all this feedback loop of getting some production data, doing some kind of some things like to make sure it's sampled to the right size, that it makes sense it can run in a few minutes, and then make sure that with a new version of the code, we do not break any vital expectation that we have at the end. And yeah, that's it. And so to conclude, so I think what I wanted to share here in this presentation is that the importance of the data test in our data products. So I think it's commonly accepted that you should test your code in our profession, but I don't think there is a lot discussed about testing the data, but it is as important or even more important because you don't really control when the data is changing. So it's a new domain, and there are I think you need more awareness around it. And yeah, as I've seen in my company, there is no silver bullet. I wish we could say, we're out, we'll just use great expectation for everything, and it will solve all our problems, all use case. It's not really the case how it worked. But yeah, we are trying multiple approaches, and there is no clear winner for us, at least in this point in time. But yeah, pretty excited to see the things going. So with that, that's the end of my presentation. I'm really looking forward for your question, remarks, or also share any experience that you have with your tests or your data and how you test and data incident that you can have. Thank you.
Thank you very much, Theodore, for the talk. I don't know if there are any questions. Stuff from here.
Thank you for the talk. My question is about some of the issues you have. Feels like they could have been solved also with some kind of data versioning, which is also something, let's say, for example, if there is some data that disappears, you could see it. There is DVC, which is popular for that. How do you think these two can be used in conjunction, or is, for example, some of the features you presented actually also being handled by some data versioning, or what do you have to say with this?
I think that's slightly two different problems. I think exactly this data versioning is also good to have, but you can version bad data without you noticing it, right? I mean, if you decide, if you do some code mistake and you take the wrong column for scoring, you can always you can version it, but it will still be wrong, and you will not notice it until some of your consumer will tell you it's completely wrong. Like, why do we have such a recommendation? And then with this versioning, I agree with you. You'll say, well, okay, it was wrong since this point in time, which is, I think, for a business, it's important to know, like to have the a scale of the incident, thing like that. But as you say, as I say, you will not get the alerting by yourself, basically. That's, I think, the main difference.
Thank you.
Thank you very much for the presentation. I wanted to know more about specific unit testing when you use filters. For example, let's say that you have you have an attribute, and you know that the ranges will differ depending on that attribute. How does the documentation in the Great Expectations framework? How does the documentation reflect that? Do you need to, does it identify whenever you slice from the original data, or do you need to actually input that yourself?
I think then here you are starting to go into the specific use case. Like, I don't know if you have if you want to have something like, let's say you have some kind of companies and the values that you expect for each market, German vs UK vs France, should have kind of different averages. Then what Great Expectation has is this concept of data, I forgot the name, but basically you can have a data set and like a subset of this data set, then you can apply a specific set of tests. Like you have a certain suite of tests, a collection of tests that you apply, but for another subset, you can apply another type of test, and for the overall data set with everything, then you can apply another one. So they have this concept, but you will have to basically specify the value for each of your different data sets in this sense.
Thanks for the talk. Just a couple of questions. I'm here.
Yeah, sorry. Thank you.
The first one is the report you generated out of running Great Expectation Suite, right? Would it be possible to export that as a PDF or a file or something, just for us to know what passed and what failed in a production system, and when we're not doing it interactively? And the next one is comparing one data set to another, right? So like you showed the distribution comparison. Would it also be possible to say, like I have, XYZ values in one data set. I also want to have the same XYZ in my second data set. Would it be possible to do stuff like that?
Really good questions. So the first one is yes. Actually, there are some technical difficulties around using Databricks, but basically what you have at the end, the output is just HTML. And so basically it's a static file, it's just a static website, and you can get like the list of expectations, and you can know which one was failed. You can see all the suites of expectations. If you want to know more, I really encourage you to go into this Great Expectation website. Then you can just have the website running on your machine basically, and you will see. The second one is comparing two data sets. Yes, it's a very common use case in ML. So basically you have like the one of yesterday, the one of today, and you would like to compare if they are good. You don't really care about like specific values. So we are exploring that. It's not native from Great Expectations. So basically what we have to do is to wrap some code around where we say, okay, we take this data set, we create some expectation around it, or like some specific thing, or you basically take a set of data set from the different days, then you can compute some kind of 95 percentile confidence interval for this average of this value, and that's the one that we'll use to compute for the next one, basically, to see like to kind of some kind of detection. So you can build that around the API of Great Expectation, but it's not native, so you will have to do it yourself.
Yeah. Thank you for the talk.
Okay, that's
yeah. So I think a question that emerges with testing in general, but I find it a bit difficult to answer well here, is when do you do enough testing, right? I think for unit testing in code, you look at test coverage or metrics like this. What do you suggest somebody would do because I find this hard to answer for data unit tests. When do you do enough testing, and how much coverage do you have of your question, essentially?
Yeah, good question too. Usually you don't have enough. That's my answer. Basically I think what you have to then have to look is what are the business impact. Like maybe you have a feature, and the feature can go completely wrong. But if it's not the top 4 more important feature for your model, maybe it doesn't need to be tested as well as the important feature. Or actually, what you care the most actually is the output, like what you will serve to customer. I think there was some great presentation about like if you want to do some kind of monitoring of a product or data product in general, you should test what you get input, but also what you will give output. But if you have to start somewhere, and you always have to start with one of them, you should start with the output. So I will say first, make sure that what you give to your customer is right, and then maybe tackle what you do in what are the data input. That will be, and make sure that you don't, because if there is some data input that is wrong, but your output is still okay, it's still okay. I think there was one. Oh, okay, sorry. He was here from the start, so.
Thank you for the talk. I'm curious that, because you mentioned that you can validate your recommendation, but is that based on like you need to come into the office every day and fairly manual, or do you have like some tool and can make it automation?
So basically it's a task. So basically you always say like you have this task that take this data set, apply this validation, and give the output. And then you can schedule it. And so what we use in our company is Airflow, but you can use any kind of scheduler to basically what we do is like we create a data set, we do the prediction, and then we do the validation. And if it's successful, then we put the prediction into another bucket where we know that now that's whether our customer will use it. And it's done automatically.
So it's like pipeline, do you mean?
Yeah, it's a pipeline. It's a DAG, basically, yeah.
How do you handle streaming data? Obviously, if you have data coming in one at a time, you can't take an average or a distribution or median or anything.
Yeah.
Do you batch it up and test it at the end of the day, or what?
So we don't have that many batch use case, but we are discussing it. So it's coming basically. But for me, when you have any batch data, basically you can always, as I say, batch it and do some expectation on the batch. And usually, let's say you have a batch every 5 minutes. What will happen, like you can really try to have a really smart process to do it really on the stream, and you will know exactly when it's happened. But if you know it 5 minutes after, it won't change much in some sense. And I think it's much easier because then you have the whole framework for all your things. You have some kind of data set that you need to validate.
Thanks very much for the presentation. I was just wondering, have you ever seen a case where your production data has actually changed through time and your old expectations are now wrong? And how have you had to deal with that, or how do you notice and monitor that?
Yes. So before doing data unit tests, what happened is people change the data, then our things sometimes failed. That's a good part. Sometimes they didn't fail. They just give rubbish. And then at sometime in the future, people will just come to us and say, why do you have this ranking or these recommendations? And that's terrible. That's what we want to avoid. And now what we do, basically, when we change, hopefully the data unit test will be the one that first will fail. And so we don't push in production these new things where we know we don't know what we are really pushing, right? And then we can basically look back into the code, look back into the data, and make sure that is this correct or not, or do we need to change our data expectation, or should we change the code, basically? So that's the overall process. But then, basically, you are in control. That's a big part. I think there's a lot of things. I think it feels bad when one of your customers come back to you and say, "Why do you have that?" And you say, "I have no idea. I have to look it up." Right? It's much better if you are proactive and you say, "I think we have a problem because of X, Y, and Z." I think it's a much better stakeholder communication in general.
All right, I think this is the last question because we're running out of time.
Hi there. I just wondered how you deal with more fuzzy failures. The sort of thing I'm thinking of is if a test you're applying finds like 1% of the values are invalid, then you might want to just ignore those and throw them away and continue, versus if 50% were wrong, then you probably should stop. So any patterns or kind of toolkit support for that kind of thing?
But actually, that's exactly the thing of like I think where the data unit tests are useful. Like maybe, for example, let's say you want to compute some kind of CTR, and then you have to look at the impression and the clicks, and you have to kind of merge them with some events, and you expect that some events will not be sent, or like you will not be able to match all of them, but you expect to match most of them, right? And you kind of have a threshold to say, I expect to have at least 95% of the events match. But I know that because system is complex and not all events have standard, I still expect this. But then you can have a test to say, if I have more than 5% of missing events, that's where I should have a trigger, because that means that there's something wrong has been introduced to the system. So that's basically where you can remove the fuzziness into putting into something. This is the point where I want to be alerted about this problem that I'm aware of, but I expect to be small. If it's bigger than that, that's big enough problem that I should look into this.
All right. Thank you very much,
Cool.
Theodore.
Yep. Thank you.